Hello and welcome to yet another riveting video over the Algebra 1 course, and this is Unit 8, and this is Section 2, and this is a section about adding and subtracting polynomials. So we talked about what polynomials were and how to identify what types they were, but we can actually add and subtract them, and that's going to be a pretty useful thing for us. So, our objectives today, we want to add and subtract polynomials. We want to determine the degree and the number of terms of the sum or difference. We want to find and evaluate polynomial sums or differences that model real-world situations, okay? So, right here you have this little thing that shows kind of like a guideline as to how to do this. So you want to rewrite terms that are subtracted as the addition of the opposite, okay? We'll talk about that here in a minute. We want to group like terms. We want to then combine like terms. Then we want to write the resulting polynomial in standard form, okay? And so we have some properties that exist with polynomials. So, what happens is we have this thing called the closure property. And the closure property means that, you're adding two integers, all right, to get another integer. Okay? And then on this one, the closure property of polynomials, it means that if you add two polynomials, okay, then you get another polynomial. So the same thing works down here. The commutative property means that you can reorder this, and this is going to be huge. Reorder numbers. You can it also works here with polynomials. You can reorder polynomials. Okay. On the associative property means that you can regroup. All right, we'll be doing that. All right, and we can do that for polynomials as well. So we when we use these properties, all right, and I'm going to do the commutative property a whole lot when we do this. And we're going to reorder so that we can, make sense of things and do all that. Okay, what I want to do here, determining the degree and the number of terms of a sum. So remember, the degree of the polynomial is the highest exponent or sum of exponents on any variable term. So what I have here is I have the sum of the following polynomials. So I have 5x cubed plus 3x squared minus x plus the polynomial 15 minus 4x minus 2x. And what I want to do is think about the degree of that polynomial. Okay, when I see this, I'm looking for my largest polynomial, or my largest degree. And so if I were to add any of these together, the largest one that I have is a 5x cubed. So my degree, all right, and so that 3 there tells me that my degree is equal to 3, okay? And what can I determine about the number of terms of the sum of the polynomials? So what I notice is that I'm going to have one term with a cube, okay? I'm going to have a term, once I combine these, I'm going to have a term with an x squared. Okay, so that's my second term. I have a third term that just contains an x, okay, and then I have a fourth term that's just a constant. So I'm going to have 4 terms in this polynomial, okay? So let's kind of talk about how I would do that and how I would actually add these together. So what we want to do, and let's go ahead and just take that same one, we want to rewrite the terms that are subtracted as the addition of opposites, and we want to group those like terms, okay? Now, like terms means we have the same variable with the same exponent, okay? So when I take a look at this, all right, I'm going to rewrite my terms that are subtracted as the addition of the opposite. And so let me just kind of rewrite this. I've got 5x cubed plus 3x squared. Okay, now I'm going to start with my x cubed, okay, because that's my largest exponent. Then I'm going to look at which one of these has an x squared, okay? So I've already done 5x cubed, I've got 3x squared. Any other x squared is this one, okay? And I'm going to write that as a plus negative 2x squared, okay, to add those together. Okay, so now I've done all my x cubes, okay, I have no more x cubes. Then I look for x squareds, I don't have any other x squareds. I have a negative x, I'm going to do a plus negative x, all right, so I've got that term, plus a negative 4x, okay, and then I've got a plus 15, all right. So now what I have is I have all these different like terms, okay, and so I have this group. I just have a single term for 5x cubed. I'll leave that one there. I need to combine these two, 3x squared plus negative 2x squared as like terms. I need to combine these two terms because they just have an x in those terms, and then I just have my 15. Okay, so I'm going to write this now as 5x cubed. All right, and then I've got 3x squared plus negative 2x squared. So, you know, and remember, guys, what I do is if I have the same variable to the same exponent, I just add the coefficients, the numbers in front of the variable. So 3 minus 2 is just a single 1, so I'm going to do a plus 1 x squared, okay? Same thing here. I have a negative x and then a negative 4x. This is like negative 1 plus negative 4, which gives me plus negative 5 x and then my plus 15. Okay, so you can keep it like this. That would be fine. But, you know, typically I would just write it as 5x squared plus an x squared minus 5x plus 15. Okay. And so, you know, you guys will get pretty fast at this. Like, I'm really fast at adding these together. You know, and sometimes I don't need to write down this second step. I can kind of just do it. But it always helps to write down if you're, you know, if you're struggling. So, okay, let's talk about adding multivariable polynomial expressions. What I want to do is combine my like terms here, and let's see what we have as far as like terms goes. Let's look at this first one. I have a 9p, okay, and that's just a single p variable. So I look at all my other terms and determine, okay, do I have any other terms in here that just have a single p, and I see that one, okay. So what I would do is I would write this down on my next step as 9p plus p, okay, group those together, and then I'm going to take the next one, which would be negative 2w squared. Do I have any other terms that contain a w squared? And I notice that I have one over here as 6w squared, so I'm going to highlight that. So now I'm going to write that down here as plus negative 2w squared and then plus 6w squared, okay? The next term that I have is a negative 3pw. I don't have any other 3pw's, okay, so I'm just going to add that in there. So plus negative 3pw. And then I have a plus 7, okay, and that's just out there not really doing anything, okay, it's just a constant. So let's think about what we can combine here, okay. I can combine the 9p and the p, so 9p plus 1p is going to give me 10p, all right, and then I have a negative 2w squared plus 6w squared, and that's going to give me a positive 4w squared, okay. Negative 2 plus 6 gives me a positive 4, okay. And then I have negative 3pw, and so I'm going to put, and that's the only one that I have, so I'm just going to put a minus 3pw and then plus 7, and that's it, okay. Now, putting this in standard form, making sure that everything goes in ascending order, what I would do just to make it look nice is I would put the 4w squared first and write 4w squared minus 3pw and then plus 10p plus 7, okay? So you can reorder this and put it in any way that you want. The reason why I did that started with the w squared because it had the largest exponent, and then my next term contained a w and then a p. All right, and so then so I wanted to have the w squared and then a w, and then because this had a p, I just put the other p over on this side, and then the constant always goes last. Okay, so all right, let's take a look at the next page. Okay, at the start of this next page, what I find interesting about this is comparing subtraction properties of integers and polynomials, okay? If I were to take, it works under the closure property, okay, as far as what you would need to do. So if I take two integers and subtract them, I'm still going to get another integer, okay? If I take two polynomials and subtract them, I'm still going to get another polynomial, okay? And so then we have, it says the commutative and associative properties do not apply to integer subtraction, okay? So you can't always reorder when we're talking about subtraction, okay? And same thing's true about polynomials. So to fix that, what we have to do is we have to think about the additive inverse, okay? So what we do is to subtract polynomial expressions, we write subtraction as addition of the additive inverse. So basically, the additive inverse, what that means is that we are going to add the opposite, okay, which is like subtraction, okay. So adding the opposite of what it is basically means that we are adding a negative, okay. So and this is a pretty loose terminology that I'm using, and so I just kind of want to talk about this for a second. So it says, what is the additive inverse of 3n to the fifth minus 3n cubed plus 5? So what you would do to find the additive inverse, you would take this entire thing and multiply it by -1 to get the opposite. So we would take -1, multiply it by 3n to the fifth minus n cubed plus 5, and basically all you're doing is making these opposites, okay? And so if I were to distribute my -1, that would give us -3n to the fifth plus n cubed, and then minus 5, okay? And if I add this, okay, add this quantity, it's like me subtracting this, okay? So let's kind of take a look at another example of how we would do this, and let's just take a look. So it says, here's some steps on how to subtract polynomials. We want to write subtraction of a polynomial expression as addition of the additive inverse. We want to rewrite terms that are subtracted as the addition of the opposite, group like terms, combine like terms, and then write this whole thing in standard form. So what I want to do is I want to subtract this polynomial from this, okay? And so to put that into words, or to put that into math, just to subtract this from that, this part goes first. And so really the problem that we have, and let me write this all out here so we got some room, is going to be negative 2y cubed plus 4 minus this entire polynomial here, okay? And so it's going to be, we're going to subtract -3 minus 2y cubed minus y minus 5y squared, okay? And so, I have this part, and I'm subtracting this quantity, okay? And this is a big misconception in algebra, is how we do this. And so what I did before, was, when I had this problem and I took this thing and had this negative outside, it was like taking -1 and multiplying it through and distributing that negative. And that's the same idea here, and that's how I like to think of it. I like to think of this as a -1, okay, a -1 that I'm multiplying by each of these, okay? And so as a result, this is what we get. I'm going to get -2y cubed plus 4. If I distribute this -1 into each of these terms, it's going to make them opposite. So I'm going to get a plus 3. I'm going to get a positive 2y cubed. I'm going to get a positive y. And I'm going to get a positive 5y squared. So basically all you're doing is taking all these terms here and making them opposite if you're subtracting that whole thing, okay? So my key is just to subtract that quantity. Make sure you put parentheses around it. Turn that into a -1 and distribute that -1, okay? So now let's think about our like terms, okay? I've got negative 2y cubed and a positive 2y cubed. So I'm going to do negative 2y cubed plus 2y cubed. All right. The next one I have are these constants, 4 and 3. So I'm going to add 4, add 3, and then I'm going to add a y. Okay, I don't have any other terms with the y, so plus y. And then I'm going to add my last one, which is 5y squared. Okay, and I don't have any other 5y squared, so plus 5y squared. Okay, so the only ones I need to combine are these two and these two. Now, what I notice here is that negative 2y cubed and positive 2y cubed, if I add those two numbers together, I get 0y cubed. Okay, and something subtracted by itself or adding the opposite is just going to turn this into 0. Okay, so you can sit down there and you can write 0 times y cubed, but 0 times any number is just going to be 0. Okay, so normally when you see the opposites, you just kind of cross them out. Okay, and then I'm going to do plus 4 plus 3 is 7, plus y, and then plus 5y squared. Now putting this into standard form, I got to put my largest exponent out front and put it in ascendant order. So it's kind of backwards right now. So I would put this as 5y to the squared plus y plus 7. Okay, and that's that. Okay, and so that's me subtracting those two polynomials. Okay, now let's talk about subtracting multivariable polynomial expressions. Now what I see here on this one is like the same thing. Okay, I am taking this polynomial here, 7hy squared plus 3h minus 4y squared, and I'm subtracting another entire polynomial from this one. So when I'm subtracting this polynomial, I'm subtracting a quantity. So I have to distribute this negative, and so I'm going to put a negative 1 out here. Okay, and I'm going to put those little signs to distribute. All right, and so here's what I get as a result. We're going to get 7hy squared plus 3h minus 4y squared. And I'm going to make all of these terms opposite. So I'm going to put a plus 2h. I'm going to put a minus 5hy squared. I'm going to put a positive 9. Okay, so now, all right, I got to look and see, okay, what are my like terms? What can I combine? And so the first term I see is a 7hy squared. Okay, the other one that has an hy squared is this term over here. So then I come over here and I say, okay, I'm going to do 7hy squared plus negative 5hy squared. Okay, the next ones contain a y squared or an h. Okay, let's do that one first. So I have a 3h, and then I have another term with just an h with just a positive 2h. So I'm going to do plus 3h and then plus 2h. Okay? And then the next term that I have is a negative 4y squared. Do I have any other y squareds? The answer to that is no. So I'm going to put a plus negative 4y squared. And then the last term I have is a just positive 9. So I'm going to put a positive 9 here. Okay, so now let's see what we can combine. Now, what I'm going to do is this, putting it in standard, let's just combine what we've got first, and then we'll put it in standard form. So I'm going to combine these two terms, okay, 7hy squared plus negative 5hy squared. So 7 plus negative 5 is going to give me a positive 2. So remember, whatever your variables are, just keep them, add your coefficients, and then you're good. So I'm going to do a 2hy squared, okay? The next set of terms that I need to combine are the 3h and the 2h. 3 plus 2 is going to give me a plus 5h. And then I've got a plus negative 4y squared, and then plus 9. Those are just single terms that I don't have to combine. So now putting this into standard form, all I'm going to do is switch these two terms here. Because this one already has a 2hy squared. It kind of has my largest, my largest degree. So 2hy squared, and then minus 4y squared plus 5h, and then plus 9. So guys, all I'm doing is reordering here, and that's it. Okay. All right, let's take a look at the very last page and see what we can do. Okay, the next two polynomial applications is we're going to write a polynomial expression that represents the perimeter of the triangle. And then if x is equal to 10, what is the perimeter? So the perimeter, you know, when we do this, we're just adding up all the sides. Okay, so the perimeter, so I'm going to take this first side, which is 8x minus 28. So 8x minus 28 plus this second side, which is x squared minus 5x, so plus x squared minus 5x, and then plus this last side, which is 2x squared minus 120, so plus 2x squared minus 120. All right, so now what we could do is you could plug 10 into all of these, evaluate them, and then and then add all those numbers together, but that's kind of a lot of work. Okay, so let's see if we can simplify this polynomial and combine our like terms. Then what we could do is then just plug in 10 at the end and get the same answer. Okay, so let's do that. And so what I want to do is I'm going to write out P equals, my perimeter is equal to, okay, and I'm going to find all my terms that just contain an x. So 8x and negative 5x. I'm going to write that down as 8x plus negative 5x. Okay, I've got then my numbers, negative 28 and negative 120. So I'm going to do plus negative 28 plus negative 120. And then, so those terms. The last terms that I have are going to be x squared and 2x squared. So plus an x squared plus 2x squared, okay? So now what I can do is I want to combine these, all right? And so 8x plus negative 5x is going to give me just a 3x, okay? And then I've got negative 28 plus negative 20 is going to give me plus negative 148. And then if I've got an x squared, so, okay, combine those two. Let's combine these two. X squared plus 2x squared is going to give me plus 3x squared. Okay? And so let's put this into standard form. So my perimeter for this whole thing would be 3x squared plus 3x minus 148. Okay? So my perimeter does depend on x. So if we do have x equal 10, okay, and I plug that in, okay, so I'm going to do that. Let's figure that out. So P is equal to 3 times 10 squared plus 3 times 10, and then minus 148. Okay, so now this is all the computation that I have to do. Okay, there is algebra involved in combining like terms, but this arithmetic is a lot easier than plugging in 10 up here and adding all those together. Okay, so 3 times 10 squared. So let's do our exponents first. So we get 3 times 100 plus 30 minus 148. Okay, and so this is going to give me 300 plus 30 minus 148. And so then this is going to give me 330 minus 148. And that 330 minus 148 is going to give me an answer of 182 feet. And that's your perimeter when x is 10, okay? And so that's the idea on that one. Okay, same thing over here. Okay, if I were to find the perimeter of this quadrilateral, okay, then I would just write out my perimeter just how I see it, okay? So my perimeter here is going to be, I'm going to take this length here, which is 31, okay, add it to this length, which is 4x squared plus 8x, okay, add it to 7x plus 30, okay, and then add it to 3x squared minus 5x, so plus 3x squared minus 5x plus 20. All right, and so what I can do there, and I just want to combine those and then plug in 2 in the end, okay? You could plug in 2 now and then add them all up, or we could kind of write out a polynomial and do some algebra. I like to do some algebra. All right, so let's do this. Let's put all of our constants together. So I got 31 I've got 30, and I've got 20. So I'm going to put all those in a row. I'm going to do 31 plus 30 plus 20. Okay, the next one I've got, I've got 4x squared. Anything with else with an x squared, I've got a 3x squared. So I'm going to do plus 4x squared plus 3x squared. The next thing I'm going to do is an 8x and 7x. Ooh, and a negative 5x. Isn't that fun? So now I've got positive 8x plus 7x plus negative 5x. Okay? So now, all right, if I do 31, 30, and 20, and I combine all of these together, okay, that's 50 plus 31, which is going to be 81, okay, plus, then I've got 4x squared plus 3x squared gives me a total of 7x squared, okay, and then plus, let's do these other ones, 8 and 7, and a negative 5 is going to give me a 10x, okay. Let's put this into standard form. So I've got 7x squared plus 10x plus 81. All right, and so my perimeter then would be 7. Let's plug in 2. So 7 times 2 squared plus 10 times 2 plus 81. All right, so 7 times 2 squared. So 2 squared is 4 times 7 is going to give us 28. Okay, plus 20 and then plus an 81. So then, all right, perimeter is equal to, what is that, 48 plus 81. So 40 plus 80 is 120. 8 plus 1 is 9. So perimeter is 129. And then the answer to that is inches. Okay? And so that's the idea. All right. The last one that we'll do is an application problem. And it says revenue in dollars of a company that produces tablets can be modeled by this equation here. So I'm going to do this. I'm going to say that my revenue, R, is equal to x cubed, x cubed plus 2x minus 500. Okay, the cost in dollars of producing the tablets can be modeled by this function, which is, so let's write that down, that the cost is equal to x cubed minus x squared plus 200. Okay, the number of tablets sold is represented by x. If profit is the difference between the revenue and cost, what expression represents the profit? So let's think about this. Revenue is the money that comes in. So money in. Okay, money earned. Okay. But to earn money, you gotta have money, and you gotta spend money. Okay, this is money spent. All right, and so if we want to find the profit, profit is what's left over. Okay, profit is left over. All right, and so we have this profit equation, which is the revenue minus the cost. Okay, so what I want to do is I want to take my revenue function, and then I want to subtract out my cost function. So my profit is equal to my revenue, so I'll do x cubed plus 2x minus 500, and then minus my cost, which is x cubed minus x squared plus 200. All right, and that's it. That's all I'm doing. Okay, so what is the expression that represents this? So we just need to simplify this. Now what I'm going to do is I'm going to turn this into a minus, or a negative 1 times that quantity. And I'm going to distribute my negative 1 here. Okay, so I'm going to get this. I'm going to get that my profit is equal to x cubed plus 2x minus 500 minus an x cubed plus an x squared and then plus 200. Or I'm sorry, minus 200. Okay, and so now what I'm going to do is I'm going to reorder this and combine my like terms. So let's combine our x cubes. So profit is equal to x cubed plus negative x cubed. I don't have any x squareds. Okay, so I'm just going to put a plus x squared there. I just have one term with a 2x, so I'm just going to put a plus 2x here. And then I've got a negative 500 and negative 200, so I'm going to do a plus negative 500 and then plus negative 200. All right, and so now, as a result, I have an x cubed minus plus a negative x cubed. That's just going to cancel out and go to 0. Okay, so then as a result, I get x squared plus 2x, and then negative 500 minus another 200 is minus 700. So if I just wanted to find the profit, I can use that function. Okay, so we could figure out how much we're earning total. We can figure out how much money we spend in our business, and then we can figure out how much we make depending on X units sold. So I know it's kind of quite a bit of information, a lot of notes here, but it's all kind of the same stuff. So hope you enjoyed it, and we'll talk to you later. See ya. Bye.